Welcome all my dear student of TYBSc physics class. In previous lecture we have studied enhancement type n channel MOSFET, and in that article we studied the working principle, then what is enhanced mode. Okay, after then we studied static characteristics, and in static characteristics we studied drain characteristics and transfer characteristics. Now today we are going to see the last point of this chapter, last article of this chapter, that is symbols of MOSFETs. First of all, we are going to see the symbol of depletion type MOSFET. Depletion type. Okay. These figures, both the figures represents symbols of depletion type MOSFET. First figure represents n channel depletion type MOSFET, and figure V represents p channel depletion type MOSFET. This figure, first figure, shows the circuit symbol of n channel depletion type MOSFET. N channel depletion type MOSFET. The thin vertical line, this is the vertical line. This vertical line, this thin vertical line represents the channel. The thin vertical line represents the channel. This indicates that, the arrow on the P substrate points towards the channel. This arrow on the P substrate, this is P substrate, is points towards this channel. This indicates that the channel is of n-type channel. Channel is of n-type. In some MOSFETs, a connection from substrate is also taken out. Such MOSFETs have 4 terminals. But in most of the MOSFETs, the substrate is internally connected like this. Substrate is internally connected to this point. Substrate is connected here internally. Such MOSFETs have 3 terminals: gate, source and drain, as shown in this figure. Okay. Now this is the symbols for P channel depletion type MOSFET. This figure shows the symbols of P channel depletion type MOSFET. The arrow on the N substrate, this is N substrate, points out away from this channel, points out from the channel. This indicates that the channel is P type. The P channel MOSFET also having 4 terminals, but in most of the MOSFETs the substrate is internally connected like this, and when substrate is internally connected like this, obviously such MOSFETs have 3 terminals: gate, source and drain, as shown in this figure. Now it may be noted that the circuit symbols of P channel depletion MOSFET is similar. Both the symbols are similar except the direction of arrow. Here in N channel the arrow is pointing toward the channel, and in P channel P channel depletion type MOSFET, the arrow is point away from the channel. Okay. Now we are going to see the next type, that is enhancement type. Enhancement type, second type. See here, in enhancement type, in this N channel, enhancement type MOSFET. And this figure represent P channel enhancement type MOSFET. See here, what is the difference between depletion type and here? Here only is the difference. This is the dotted line. That means there is a no channel. There is a no direct channel because we studied the structure of enhancement type, and this is the enhancement type. This is silicon, this is the metal, this is also a terminal substrate, this is gate, this is drain, and this is source, and this is the P substrate. Okay. See here, as there is a P type of substrate, thin layer of P type of substrate is constructed here, and hence these two N channels, this N layer, N type of layer are separated from each other, and hence there is no channel. And this is indicated in both the figure by this dotted line. First figure A represents the circuit symbol of N channel enhancement type MOSFET. The broken line, this is broken line, not continuous line. This is broken line. Broken line represents there is no conducting path, there is no conducting channel between drain and source, or between source and drain. The substrate is internally connected here. In both the figures, here and here also, substrate is internally connected. Okay. Now, the substrate is internally connected to the source as shown in both the figures. Figure B shows the circuit symbol for P channel enhancement type MOSFET. Again, here is both the figures are similar except that in N channel MOSFET the arrow points toward the channel, and here P channel MOSFET arrow point away from the channel. Okay. In actual practice, the N channel and P channel enhancement type MOSFETs are known as NMOS and PMOS FET. What I say? In actual practice, when you are searching in market, then you will find that N channel and P channel enhancement type MOSFETs are always known as NMOS and PMOS FETs respectively. Okay. Now we are going to see the applications of MOSFET. Applications. What are the applications of MOSFET? There are a number of applications, but here we are going to discuss some important applications. Applications of MOSFET. What I say, there are variety of applications, there are number of applications, but here due to lack of time we are discuss only some important application. So first important application is that MOSFET can be used as a passive element. First, MOSFET can be used as a passive element, that is rather than active. And in passive element we know electronic component like resistor, then capacitor, then inductor. These components comes under this head. So MOSFET can be used as a resistor, capacitor and inductor. Second important application is that it can be used as an electronic switch. And this is very important application because this is having MOSFET is having very high switching time. Okay. Therefore, there are very important application. There is very important application that MOSFET can be used as an electronic switch. And last one, MOSFET can be used as a high frequency amplifier. High frequency amplifier. This is also very important application. Now we are going to see advantages of N-channel MOSFET over a P-channel MOSFET. N-channel MOSFET over a P-channel MOSFET. And then we can see how N-channel MOSFET is versatile. Okay. See here. Advantages. Of N-channel MOSFET or P-channel MOSFET. There are number of advantages for N-channel MOSFETs when we compare it with P-channel MOSFET. There are number of, but again here due to lack of time we are going to discuss on only few advantages. First one, N-channel MOSFET has charge carrier N-channel has electron as a charge carrier. What I say? N-channel MOSFET has electrons as a charge carriers with which we have very high mobility. We know that electrons are having more or high mobility, and that's why we can say that N-channel MOSFET has electrons as a charge carrier with which have very high mobility. Second advantages, N-channel MOSFET has a very high drain current, that is ID, very high drain current for the same dimension as compared to P-channel MOSFET. Third one, N-channel MOSFET has a very low on resistance. N-channel MOSFET has very low on resistance as compared to P-channel. Next advantage is that as compared to P-channel MOSFET, N-channel MOSFETs has very small size. Okay. And last but not least, as compared to P-channel MOSFET, N-channel MOSFET has higher packing density. What I said? This is also very important. As compared to P-channel MOSFET, N-channel MOSFET has higher packing density. Okay. Then, next point is that handling precaution. When we are going to use the MOSFET in our laboratory or in any practical, then we should have to take some precautions. Otherwise, the use of MOSFET is going to fail. Okay, so which precautions should have to take? So make your concentration here. Handling precautions. handling precaution of MOSFET. MOSFETs. Remember that if MOSFETs are not handled properly, it is damaged easily. What I said, if MOSFETs are not handled properly, it is damaged easily. The damage may be occur due to static electricity. Damage may be occurs due to static electricity. Okay. In order to protect MOSFET from damaging, there should be some precautions, and that's we have to take during the use of MOSFET. First one, it should be kept, MOSFET should be kept with its three terminals shorted by a ring. Suppose that this is the MOSFET and this is having three terminals, source, gate and drain. Before connecting it in practical circuit or in any circuit, it should be kept. It should be kept with its terminal shorted. This terminal, all the terminal is shorted by a ring. Okay. Second precaution. The ring. If the ring is shorted, the MOSFET, or what we can say, the ring shorted the MOSFET should be removed at the time of soldering only. Suppose you are going to prepare some circuit, and when you are going to solder the MOSFET in the circuit, at that time you should have to remove the ring. Okay. Next precaution, it should be kept in conducting system. MOSFET should be kept in conducting system. And last one, it should never be inserted. MOSFET should never be inserted or removed from the circuit with power on. What I say, this is very important. It should be removed. MOSFET should be removed or inserted from the circuit when power is off. And when power is on, then don't try to insert or remove the MOSFET in that circuit. Okay. These are the precautions which we should have to take when we are going to use the MOSFETs in laboratory or in practical purpose. Okay. In next lecture, we'll see the advantages of MOSFET over JFET and then some problems. Till then, we shall stop here. Have a good day. Thank you.